Welcome to Coding with Sonali. So today in this session we will be understanding about the array operations which are performed. So here we will be seeing different operations which are performed on the one-dimensional array. We know what is an array. Array is a collection of n number of the elements of the same data type which are arranged in the contiguous memory location one after the other. So we have already seen the details in a couple of sessions for the array, and here we will be seeing these operations as well as we will be also writing the program in C language, and we will be seeing the very important factor, that is time complexity, which is required for these operations. So we will see the worst case, the best scenario, what will be the algorithm, what will be the formula in terms of the theta, how much time it will be taking. We also know about the array. The size of the array is fixed. Let's see the very first operation which is performed on the 1D array, and that is the insertion. What is this insertion? Insertion is inserting the element in your array. So insertion can happen at the beginning of the array, or it can happen at the end of the array, or at any position in the array. So we will be seeing here this first insertion and what is the logic to perform the insertion operation of an element in the array, and we will also write the program. We will see at different positions how to insert the element, and we will be seeing the time complexity. We will be seeing for the sorted array as well as for the unsorted array. Next thing, we will be seeing the deletion operation in the array, how and what logic is required. We will be writing the program in C language. We will be seeing how to search then the element in the array. Then we will see traversing in the array and updating. So updating means the element which is present, if we have to update that element by different value, then we will be performing that operation. And the sorting. So the sorting portion, first of all, we will be covering in different sessions. There will be couple of sessions dedicated for sorting. Now let's see these operations one by one in the array, and let's write the program for that. First, we will see the insertion operation in the array. So this is the snippet of the code. Main function is an entry point to start an execution of your program. So the control comes here, and line by line the instructions will be executed. Here we will be doing the runtime initialization of the array. That is, we know that in case of the runtime, we will simply declare the array, the size of the array, and at the runtime we will be asking the user to enter the elements which we will be filling in the array. Then we will be asking the user to enter the position where the user want to insert the element. This piece of code we will be writing, we will be understanding that, and then later we will be seeing how to perform the insertion at the beginning as well as at the end, and we will be seeing the time complexity in each of these scenarios. So we'll be seeing for the sorted as well as for the unsorted array. So here you can see that we know that in case of the array the size is fixed, therefore I have done hash define maximum 50. So I have mentioned that the capacity of my 1D array, so much memory will be allocated for this array. The size I will be using here in my array. So in the main function you can see the very first line is what? Int ARR subscript maximum. So this is one dimensional array because we are having only one subscript and we are mentioning the size. So max is what? I have already defined it to 50. So I want this capacity of this array to hold so many elements, and then the next variable is size and next is pause. So pause indicates for the position where the user want to insert the element, and size is what? So I am asking user how many number of elements the user have to occupy in this capacity of the array. So the capacity of the array is 50, but if the user want only 10 to fill only 10 elements in the array, so that is the size. So always we have to check whenever we have to ask the user how much elements the user want to fill in the array, as well as we have to also check whether this number of elements is not exceeding this capacity, because in case of C language the compiler does not perform array out of bound. Array out of bound is what actually if the capacity of the array here we have mentioned is 50, and if the user is crossing this limit, is entering more number of elements greater than the size of the capacity of the array. So in that case, that problem which can occur is array out of bound. So first of all, by default the compiler does not provide this provision. You have to make sure that in your program itself, whatever program you write for the array, you will do that checking in your program itself. So in this portion of the code, what I'm doing is actually I'm just doing the runtime initialization of the array. And for that I have declared the array, the size. I have asked the user to enter the size, how many number of the elements user want to fill in this capacity of the array. So we are asking the user to enter the size, and this size, then for that I have checked this error, that is array out of bound, as I told you. Now that what we have to see if that is not crossing the maximum size. So if it is crossing the maximum size, then we have to display this message, that is array out of bound. This is very much necessary in order to avoid the runtime error. It can happen that because the compile time, if you are not checking this, you are not checking this condition, in that case what will happen if the user enters more number of elements, and if your user is trying to access that, so runtime the error can come, because compile time, this checking is not provided by default by the compiler and you have not ensured in your program. So in order to avoid those errors, it's better you write in your program this check which is required, array out of bound, and then if the size is not exceeding the maximum limit actually, well and good, then only you can allow the user to enter the elements. So therefore in else you can see here, if this condition is not satisfied, then it will go in the else condition. We are giving the message, printf is used to display the message on the console. We are asking the user to enter the elements, and then we are taking the for loop. We know that if the user enters, suppose the size, here I have taken this array, and I considered taking the example that if the user enter the size 7, so therefore we know that maximum is 50, so this condition is not satisfied, well and good, then we will ask user to enter the elements, and then I'm taking the for loop. We know that the for loop we use actually to iterate over the complete array one by one, element by element. So I is equal to 0, I less than the size. So whatever the size user have entered, say we are considering here 7, size as 7. If user enter size 7, then we will try to fill. We are calling the scanf function, and we are trying to fill the array elements one by one. So you can see here we are using the format specifier %d because the elements are of the data type integer, and the address. So at this address of this element, actually we know when I is equal to 0, then this will ampersand a of subscript 0. That means at this address of this element, whatever the user give the value, we will be filling in the address of this element. Again, one by one we will be iterating till size 7, till 0 to 6 index, all the elements we are accepting, we are asking the user to enter the values, and we are filling in the array. So suppose after all this operation, the array is filled actually, and these elements the user have entered runtime. So after execution of these instructions, finally the array is filled by these elements 5, 2, 3, 4, 1, 7 and 9. Now the role comes actually to insert at the given position. So what we will be doing. So here what we are taking the scenario in which the input is what we are asking the user to enter the position where the user want to insert the element, and one input this we are asking the user, and the second input we will be asking the new element which user want to insert. So we will be considering first this scenario before writing the program. Let us see what is the position. So we know that in case of the array, the indexing starts from, this is index, starts from 0 to n minus 1. So we know that here the size is 7. So therefore 0 to 6 actually will be the index of the array elements. Now what is the position? So position we always consider like at the 0th index we will consider the position to be 1. At the 1 index we will consider position to be 2. At the 2 index we will consider position to be 3. So we will consider the position 1 greater than that of the index. So if the user want to insert the element at the position that is 3, that means the index will be 1 lesser than that of the position that is 2. So that we will consider. So you can also take the position starting from 0 to n minus 1. But usually we take the position 1 greater than that of the index. So I have taken from 1 to n. We ask the user to enter the position, we should check some condition, and that is if the position should not be lesser than 1. So that we have to check. That is the position, if the user enters 0, then we will give invalid position. If the user enter the position, that is size is what? 7. So position should not be greater than size plus 1. Why size plus 1? It should not be greater than that, because we know that position is starting from 1 to the size actually, that is 7, and it can happen that the user want to insert the element at 8 position. So we know that we can insert at the end, but it should not exceed more than that. So therefore position should not be greater than size plus 1, that is 7 plus 1 should not be greater than 8. You have to check all these type of the scenarios. If it is a valid position, then only we have to ask the user to enter the new element which the user want to insert. Let us see what code we will be writing. If the user enter the position as 3 and the new element which we will be asking the user, if the user give it as 10, at position that is 3, the user want to simply insert this element that is 10. You can see here. So in that case what will happen? So first of all, these elements which are if we have to insert 10 at position 3, then what things we have to do? We have to shift this 3, 4, 1, 7 and 9, all these elements onto the right side by 1 position, so that we will get here the space actually. That means we can simply insert this 10 actually at position 3. So I hope so you got. If the user is giving this position 3 and the element as 10, that is at this 3 the user want to insert this 10. So it cannot happen that we will replace this old element that is 3 by 10. So in that case we will lose the data. We don't want to lose the data. We want to maintain the old data as well as the new element which user want to insert. We have to insert that element also. In case all the elements we have to shift by 1 position. Then we want to insert 10 at the position 3. The 3, 4, 1, 7, 9 we want to be shifted by 1 position. So what about if we shift 3 here actually to the next position? In that case we will lose the data, that is 4. So you can see if we start shifting actually from this position to end. So what will happen? So this 3, if we shift here actually, this 4 will be replaced by 3. So in that case we will lose this data 4. We don't want that. So therefore how we should start actually shifting the elements? Instead of shifting from the position to end, we will start shifting from the end to the position, that is vice versa. That is what we will do. We will simply we will try to shift this 9 actually. That is first of all we will try from the end. So the end is actually, that is at the index 6. We will try to shift this 9 element actually to the next position by 1. So that is at 7 we will try to shift this 9 actually to the 7, because in after 9 there is nothing present and the capacity is first of all 50. So we can try to insert the element. We have that capacity. So therefore and there is no element present here. Nothing will get override because no element is present into the next position of this 9 element. So therefore we will try to shift this 9 here. So when we try to shift here 9, we will get here 9, right? So we will get here 9 actually. Then what we will do, we will try to shift this 7 to the 9 actually. 7 will go here in this manner, and then this 7 will be overriding this 9. So first of all we have shifted 9 to this position. So if we shift 7 at this position, no problem actually, because already we have saved 9 to the next position. I hope so you are understanding. Then what we will do, we will shift 1 actually to the 7. So in that case what will happen actually? Then in that case what will happen? Here comes actually 1, right? Then what we will do actually, we will try to shift this 4 actually, that is here to the next position. So therefore 1 will get replaced by this 4. I hope you are getting. Then we will try to simply shift, here we are at this position, that is the position which user have asked to insert a new element. So we will shift this 3 actually, that is at this position. So again this 4 will be getting replaced by this 3 actually. So therefore here comes 3. So finally, as I told you, we will be starting from the end, that is at index 6, but we will be continuing this shifting actually till the position, that is 3, till the position which wherein the user want to insert the new element. So in that case, what will happen? 3 which is there, it will be going here, that is at this position, next position. Now you can see here we are having 3 here also, as well as we are having 3 here also. That is at 2 places, that is 3 here as well as we are having 3 here. So now we can simply in the next line we can simply override this 3 actually by the element which user have asked. User have asked actually the element 10 to insert. So at this position, we know we have simply saved this 3 actually at the next position, that is at the index 3. So therefore we are having 3 double times. Therefore at this position now we can insert this element, that is 10. So I hope so you understood the logic. What will be the loop actually? It will be from the index till this position actually. But the in case of the position, we know that what will be the index at that position? Index will be 1 lesser than that of the position. So what loop will be running actually? So just loop should be start from this last index, right? So therefore it will be simply I is equal to size minus 1, and till what time we should do this actually? So I should be always greater than, we know that it should be greater than or equal to position minus 1, I minus. Yeah. So I have started actually the iteration will be starting from this index. So therefore it will be size minus 1, that is 7 minus 1, that is index 6. We will start from that. We will be decrementing therefore, because we are going from end to the position, that is we are going in the reverse order. Therefore we will start the index from this 6 and we will decrement 1 by 1. Therefore I will written here I minus, and this middle condition is what? It should be greater or equal to pos minus 1. Pos is what? Position. So position we have given here 3. So 3 minus 1 is what? 2. We know that at position 3 the index is 2, right? We will perform the logic. We will see how to perform the shifting, but the iteration should be from end to the position. Therefore I should be greater or equal to 2. That is till this actually we want the shiftings. So what logic we should be applying for shifting? So since what we are doing actually, when I is equal to size minus 1, that is I is equal to 6, A of I plus 1 is equal to A of I. So what is this actually? Is minus 1, that is I is equal to 7 minus 1, that is I is equal to 6. Therefore I have written here simply A of 6 plus 1, that is this element what you want 9 to come. So for I is equal to 6. So A of 7 is equal to A of 6. So when I is equal to 6, A of 6 plus 1, that is A of 7, it is equal to A of 6. So therefore this A of 7, that is actually here we want actually what? A of 6. What is A of 6? A of 6 actually is which element? It is simply 9 element. So therefore we will get A of 7, that is here actually we will get 9. Right? So now in the next iteration what will happen? I will get decremented and this condition will be checked. So I becomes equal to 5. Then simply in that case 5 plus 1 is 6 is equal to A of I, that is 5. So therefore A of 6. So I want here actually A of 5. So what is A of 5? It is simply 7. So now again when I becomes equal, I gets decremented, I becomes 4. So I is this actually. So at here actually what we will be doing? Again at this A of 5, that is this one will be equal to simply A of 4. So therefore this one, it will be equal to 1. So A of 5 will become 1, that is this one which I have highlighted by the green color. So A of 5 will become 1. So this we will do. Then again the 7 will get replaced by 1. So therefore I have cancelled by red color. So in this way actually we will be simply doing these operations until how much actually I greater or equal to pos minus 1 and gets decremented to 3. So therefore 3, what will happen? This will become 4 and this will become 3. So a of 4. So a of 4 actually will get replaced by this a of 3. What is a of 3 actually? It is simply this 4. That is this one. So this a of 4 becomes equal to 4. And this 1 will be getting replaced by this 4. And I becomes equal to 2. Next time I gets decremented, I becomes 2. In that case, a of 2 plus 1, that is 3, is equal to 2. So first of all, when I is equal to 2 actually, that is, this is I is equal to 2, the position is 3. So therefore what we have checked here, first of all, in that case when I becomes equal to 2, whether this condition is satisfied, what it is saying, yes, we want actually I greater or equal to pos minus 1, that is I greater or equal to 2. So I is equal to 2, therefore this condition is satisfied because I is greater or equal to 2. So it is equal to 2, therefore the control comes here. Then a of 3 is equal to a of 2, that is this at this actually a of 3 will be equal to a of 2. Therefore this 3 actually will be replacing this 4. So therefore we have cancelled this 4 and it will be replaced by this 3 actually, right? Now finally we are at the position 3 and index 2. Now again the I gets decremented to 1. When I gets decremented to 1, then this again condition is checked. So I is greater or equal to 2. We have given that. But I is equal to 1. So therefore this condition is not satisfied and then we are stopping. The loop will come out of and the control comes out of this loop actually because we wanted till position 3 and index 2. Now index is actually I is equal to 1. So this is, we don't want now the further shifts. Because till this position we wanted. So we have till this position what has happened. This 3 actually has shifted here, has replaced 4. And now we are having 3 here at position 3 as well as position 4. Now we have maintained this 3 at the next position. So therefore what last line we have to write in our program, the last line which we have to write out of this for loop is a of pos minus 1 is equal to, so the new, suppose the new element which user have entered, I have taken in the variable val, that is of the data type integer, so that I will do that. So this is the new element. So what is pos minus 1? 3 minus 1 is what? 2. So at a of 2 actually, that is this index, I will be simply storing now the new element, that is 10. So I hope so you got the logic. So this piece of code we will be writing. I will be writing the fresh snippet of code for inserting the new element at the position. That is the piece of code which we have seen. I have written here. So let us see first what we are doing. So the new thing which we are doing, which we will be adding in our program. So I have erased the earlier part. So first of all, we will be declaring earlier the integer. In the main function at the starting line, we will be declaring this val. What is this val val? It is a new element which we will be asking the user to enter, which we want to insert this element. That is val. So now we will in the next statement actually, that is in the main function, we will be asking user, we will call the printf function displaying the message enter the position. So user will understand, yes, user have to supposed to enter the position. So therefore we will call scanf to accept the input from the user for the position. So we are taking this POS, that is to store the value which user enter and the address of this variable position. So position we will store and then we will do this type of check. This type of check is very much required, which I have mentioned, that we will be seeing that the position should not be lesser than 1. The position, it should not be lesser than 1 because we are seeing that the position starts from 1 to n. So therefore it should not be lesser than 1. If it is lesser than 1, if the user give position 0, then we will give invalid position because we are starting from position 1, not from 0. So therefore we will do these checks. And I have used this OR actually. You can see this represents the or if the position greater than 8, that is because at 8 position actually this is the position 7, so at 8 position, that is at the end, we can insert, right? So therefore if the user is exceeding this position, that is exceeding giving the position as 9, so that is not valid. At 8 position also you can insert, because that is the last position of your array. That you can insert that, but you cannot insert at position 9 there directly. So therefore, in that case, we will be simply giving, actually displaying the message as invalid position. Now, if this is not satisfied, well and good, that means the position which user has entered is correct, is valid position, then we will go, the control goes to the else block. Actually here, this in else block, then we will try to insert the element. So we have to make sure actually the position, if it is valid, then only, and that is as in I have run this instruction in else. So then we will ask the user to printf, that is enter the new element. We are asking the user to enter the new element which user want to insert. Scanf, we will take the input from the user, we will collect that new element in the variable where, in the address of that variable, and then we are running this for loop. So this for loop which I have explained you the logic, the same piece of code I have written here. Then we will start from end to, that is I is equal to size minus 1, and till how much it should go, till position minus 1. And I minus 1, minus, because we are starting from last to the position. Therefore, we are decrementing I. And therefore, A of I plus 1 is equal to A of I, which we have seen actually that how to do these shifts. Now, and then after this thing, when we reach actually, when we reach at this position, then the control comes out of this loop at this piece of code, that is A of pos minus 1, that is A of 2 is equal to, that is at this index, we will be simply inserting the element that is 10, that is equal to val, right? And now you have seen actually the earlier the size was 7, but now after inserting the element the size have incremented by 1, right? So the size will be, after inserting size becomes as 8. So that piece of code we should not forget, and therefore after this, I hope so you can see here what I have written. Let me write here, size plus plus. Why the size plus plus we are doing? Because we are adding one more element, therefore the size will get increased. So we have to update this variable, therefore size plus plus. So you can understand actually how many shifts we have to do actually. If the position is here, that is 3, so we have to do that much amount of shift. What about if the position is at the beginning, that is at the 1 actually? See, therefore all elements we have to shift onto the right side. Therefore, how many shifts we have to perform actually? Therefore, we have to perform the shifts depending upon the size of the array. What about if we have to insert the element at the end of the array? That is, user has given the position as 8 actually, because we know that position starts from 1 to n. If the user give the position 8, so we don't need to shift any elements. Well and good, actually we can directly write A of 6 is equal to that new element which user want to insert. If the user give the position as 8, simply we can do here A of size equal to simply the new element, that is val. There is no time taken to insert the new element at the last position. But if the position is in the middle of the array, or position was at the 3, so we have seen how many shifts is required, and minus, that is number of elements minus position, that much number of shifts is required, is equal to 3. Then total how much time complexity will be there actually, number of elements minus the position, that much time is required. If the position is at 8, that is the last position, then simply no time is required. Therefore we will be having the time complexity to be O of 1 actually, order of 1 in that case. The time complexity will be order of 1, because at the last position we don't want any, we don't require to do any shifts directly, and therefore it is very much time efficient. It will not take any time. It is a very best case if the position is 1. How much time it will take? That is at the first position. So you can see here, in that case it will time taken will be equal to n. So O will be equal to n. So it will take, it is a very worst case actually if we have to insert at the beginning. So many, all the elements we have to shift to the right by one position. So therefore n, it will take so much amount of time. So that is a worst case.